Hello, boys and girls. If you can see me, please let me know and say hi in the comment box. Please let me know. All right. I hope I am live and everyone can see me and everyone can hear me. Hello, boys and girls. Please let me know. The chat box, is the live chat is just a little bit delayed, so I can see your hi, sir. How are you? Yes, so yes, you guys are coming up. A very good evening to all of you. How are you guys doing? And thank you for coming up. Today we are doing the last bit on this doubt destroying series, and we have named reactions and its application. So some good questions, some reactions, named reactions submitted by you. Sir, please solve some reactions for us, or please give us the mechanism. I'm doing that only, right? So let's start that, boys and girls, without wasting any time. Hai. Let's hop into it. And yes, my name is Harsh Maheshwari. If you have, if you have been following me, very good. And I believe one thing, what is that? जो करो मजे से करो. And I am from NIT Warangal, and I believe in that firmly, right? मैं बहुत बहुत firm believer हूँ इस चीज का. जो करो मजे से करो. It will be always productive. All right, moving on. Boys and girls, this is the schedule for the week. Please, again, I'm reminding you, take a screenshot of this entire schedule so that you'd be knowing when your teachers are coming live. And yes, for this, one more step is required. You have to join the, you have to subscribe to our channel. ये भी बताऊंगा इसके बारे में about the thing. I'll talk about this, in a detail, in detail. But this, you have to subscribe and click on the black, this one, bell icon, so that you will be notified when your teachers are coming. Okay? When the favorite teachers are coming, you can actually come and join their class. And yes, boys and girls, many of my students had been asking me, sir, we want to do some advanced level questions. We have, prepared enough for mains. And many of my students are asking, sir, we have done, questions, but we are losing our morale. We want to do more questions. Boys and girls, both the cases would be solved if you will join this crash course. Here we are giving you questions, we are giving you doubts, doubt discussion type, we are giving you test series, we are giving you content. So everything is there in this crash course, and the best teachers are taking it, right? And if you have missed out on anything also, 27th April से ये स्टार्ट हो रहा है, सो इट विल बी अमेजिंग, बहुत अमेजिंग रहेगा. सो यू आर नॉट इवन मिसिंग आउट ऑन एनीथिंग. इट विल बी अमेजिंग फॉर ईच एंड एवरी वन ऑफ यू. You will join this crash course and you will get a lot many things out of it. So you will be doing questions every day, content you would be getting. So overall what will be happening, you will be consistent and you will be learning. And yes, advanced level questions, many of my students ask me, sir, advanced level question कराओ यार, कुछ करना है. तो वो सब यहाँ पर हो रहा है. Everything is happening here, ठीक है? It is everything is happening here. You have to join, you have to attend, ठीक है? बहुत amazing है. And best part, it's coming at a very very cheap price, not very expensive. Use the coupon code. If you can use this coupon code, it would help you a lot. The course, which is of around 25,000, will actually cost you around 6,000. And what is the best part? Content, teachers, live discussions, your test series. So you will be continuous. And yes, advanced questions. Don't forget that advanced questions यहाँ मिलेंगे. ठीक है? Now let's start the class. ठीक है? And if you are really interested in advanced level solving, or advanced question solving, definitely be a part of this crash course. All right. ठीक है बच्चों. So सबसे पहला, the first question I got from Mohit, right? He's from Indore. He's like, sir, please let me know about this Core-House synthesis and Hunsdicker reaction. So both of them I have taken. Core-House synthesis, I think it's a beautiful reaction. So let's discuss first Core-House reaction. देखो, तो Core-House synthesis, if I talk about, boys and girls, बड़ा simple है, बड़ा easy है. Basically, you are forming Gilman's reagent. So Mohit, I'm going to make Gilman's reagent here. And Gilman's reagent is a beautiful source of carbon ion. बिल्कुल RMGX की तरह काम करता है बेटा, ये बिल्कुल RMGX की तरह काम करता है. It is a beautiful source of your Gilman's reagent. ये याद समझ के रखना, मतलब beautiful source of R minus, and it works exactly like your Grignard reagent. तो यहाँ से R minus मिला बेटा. मोहित, then तो next step is very easy. It is going to attack in an SN2 manner, and it is going to form an alkane. And I'm very happy to tell you, it is a beautiful method. I hope you will understand this point. It is a beautiful method of making. It is a beautiful method of making ऑड एल्केन्स, राइट। ऑड एल्केन्स बनाने का बहुत अच्छा तरीका है। इट्स अ ब्यूटीफुल मेथड ऑफ मेकिंग ऑड एल्केन्स, राइट। बड़ा सिंपल सी रिएक्शन, बड़ी सरल रिएक्शन है, देख लो। कुछ नहीं करना है यहाँ पर। अगर मैं एग्जांपल दूं आपको, सॉल्व इट राइट नाउ। फॉर एग्जांपल इफ आई ऐड हियर, यू नो, so beta, from here what I will get? I'll get R minus, that is nothing but CH3 minus. What it will do? It will attack here, Br minus is out. Simple. That's the way you do it. Very simple reaction, कुछ है नहीं इसके अंदर, ठीक है। बड़ी सिंपल सी रिएक्शन। इट्स अ ब्यूटीफुल मेथड ऑफ मेकिंग एल्केन्स। एल्केन्स बनाने का बहुत अच्छा तरीका है। सो कोरे हाउस सिंथेसिस, इट्स अ ब्यूटीफुल मेथड। वी विल गो बाय गिलमन्स रिएजेंट, विल मेक गिलमन्स रिएजेंट, ठीक है। विल मेक गिलमन्स रिएजेंट, एंड गिलमन्स रिएजेंट इज अ ब्यूटीफुल सोर्स ऑफ कार्ब anion, right? It is a beautiful source of carb anion, and it will act as a nucleophile, and that will attack, right? बड़ी simple reaction थी। Next, moving on, which is a very good reaction, that is Hunsdicker reaction. Hunsdicker reaction is a beautiful reaction, Mohit. Let's talk about this. काफी amazing reaction है Hunsdicker reaction. So talk about that. देखो, काफी complex mechanism दिया है. I'll give you a very simple mechanism. I'll give you a very simple mechanism. तो check this out. बड़ा ही simple सा mechanism है. ध्यान देना. ध्यान दीजिएगा. Very simple mechanism I will give. You have RCOH. When you add AgOH in the presence of bromine, what you end up getting? You end up getting AgBr. Basically, entire COOH group gets out, निकल जाता है, right? Gets out. पूरा entire COOH group gets out. Now what happens? Here basically, let me teach you the mechanism. Very simple mechanism. Pay full attention because I have a very good question for you guys. Very good questions for you guys. ठीक है, एक बड़ा अच्छा सा सवाल है आप लोगों के लिए, जरा ध्यान देना। देखो, R C double bond OH. When you will add here AgOH, what will happen? It will become R C double bond O minus. Very good, simple. And basically silver salt you will get. This R C double bond O minus, bacha, what it will do? It will actually react with Br, bromine, right? It will attack in this manner. Check this out. So what you will end up getting? You'll end up getting R C double bond O Br. ये बड़ा इंटरेस्टिंग है, यहां से सब कुछ चेंज होगा। इट इज वेरी इंटरेस्टिंग। दिस इज Br. आई होप यू गाइस कैन सी, यहाँ पे Br है। आई होप यू गाइस कैन सी, ठीक है। नाउ दिस इज वेरी इंटरेस्टिंग, यहां से बड़ा ही इंटरेस्टिंग है। चेक दिस आउट, व्हाट विल हैपन। तो यहाँ पर जो होने वाला है, लेट मी टीच यू। हाँ जी, ध्यान दीजिएगा। सो वी गॉट R C double bond O Br. Beta, this is a very slow step. It is the rate determining step. This will undergo homolytic cleavage. Homolytic cleavage will happen. You'll end up getting RC double bond O radical plus Br radical, right? And this again is not very stable. This will undergo further, this will further undergo this cleavage, देखिए, like this, and you will end up getting R radical plus CO2, right? And Br radical is in the mixture. So this Br radical will react, and you'll end up getting RBr. Correct? So what is the intermediate in this reaction? If I ask you what is the intermediate, the intermediate was radical, right? Alkyl radical. Okay? Alkyl radical is the intermediate. Now pay full attention. I have a beautiful question for you. Check this out. So if I will give you CH3 COOH, I add here AgOH in the presence of bromine. What you will get? You'll get CH4. Simple, right? What do you have to do? Oh, I'm really sorry, not CH4. Please allow me to correct it. CH3Br. What you have to do? You have to remove COH. आपको COH हटा देना है, right? Let me give you an example. A beautiful example which can definitely come. बहुत सुंदर example बनता है. You guys have to solve. You have to give the answer, right? You guys have to give the answer in the comment box. Check this out. बहुत amazing question है. 1, 2, 3, 4, 5. Yeah, let's do this. Yeah. Tell me the answer. What will be the answer, बच्चा? क्या होगा answer? Giving you first question. What will be the answer? ये बड़ा इंटरेस्टिंग क्वेश्चन है. Give me the answer. Just give me the compound name, sir. This will be the compound I am giving you in the comment box. Then I'll ask you how you are getting it. Then I'll ask you how you are getting it. Cyclic compound, someone said, very good. Cyclopentane, someone is saying hexane. Boys and girls, dekho. So you're getting the idea of it. The reaction is passing by, by a free radical mechanism. So what will happen? I'm just gonna make a free radical. Check this out. One, two. So देख लीजिए. This will couple up. 1, 2, 3, 4, 5. 5-membered ring will come. So cyclopentane was the correct answer, not cyclohexane. Count the number of carbons. Like it? Similarly, one more question I have. Similarly, I can give you one more question. देखिए जरा ध्यान देना. Let's go for this question now. Let's see who will get it. Be very careful. Very interesting questions these are, right? Kind of a different question from what you are always, what you are always prone to learn that particular part. It is kind of different from that, but it follows the same mechanism. If you know the mechanism, you can solve it. Similarly, solve this also. Similarly, solve this also. Same reagent, same reagent. So what is the answer for first one? No beta, it's not benzene. Are you guys getting this for first compound? uh, are you getting this one? Yeah, aisa. Are you guys getting this for second? Are you guys getting this? I hope it is visible. सबको दिख रहा है? Yes, it is visible. If you guys are getting this, give me a thumbs up in the chat box कि yes sir, मुझे समझ आ रहा है. I am getting all the answers correct. मैं सिर्फ radical बना रहा हूँ. What I have to do here, I have to make a radical. Here I am going to make a radical. Here I am going to make a radical. Here I am going to make a radical. Right? Correct है? इसमें एक छोटा सा गलती कर दिया है. इसको एक छोटा सा इसको थोड़ा सा करेक्ट कर लेते हैं. Just let's finish. हाँ. Now give me the answer for this one. आपको सिर्फ रेडिकल बनाने हैं. क्या काम किया है मैंने यहाँ पर? सिर्फ रेडिकल बनाया है. एंड देन रेडिकल विल अंडरगो साइक्लाइजेशन वेरी 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 रैपिडली. यहाँ पे एक रेडिकल बन गया. राइट? दे आर जस्ट पेयरिंग अप. हाँ वो बनाऊंगा. क्यूबेन भी बनाऊंगा. अभी क्यूबेन बनाऊंगा. क्यूबेन बना नहीं है. दिस इज स्पाइरो कंपाउंड. यस. आर यू गाइस गेटिंग अ स्पाइरो? यस स्पाइरेन. वेरी गुड. एक और क्वेश्चन ले लो. वन मोर क्वेश्चन फॉर यू गाइस. मैकेनिज्म बड़ा सिंपल सा है यार. बड़ा सिंपल मैकेनिज्म है. रैडिकल बनाने हैं. ऑल यू हैव टू डू इज मेक अ रैडिकल and just do the thing. They will pair up. That's it. It's this reaction is faster as compared to the normal reaction. This radicalization and this reaction which is happening intramolecularly will happen rapidly. AgOH and bromine. Let me know what is the answer in this one. This is your favorite compound. Let me know what is the answer. हाँ यहाँ पर बन जाएगा क्यूबेन. Is it interesting now? मजा आया? पेशेंस इज द की. ठीक है. क्वेश्चन एकदम से थोड़ी स्टार्ट कर देता हूँ अच्छे वाले. थोड़े क्वेश्चन वेट करना पड़ता है. राइट? दिस कंपाउंड इज कॉल्ड एज क्यूबेन. एक वन क्वेश्चन फॉर यू गाइस. टेल मी द डिग्री ऑफ अनसैचुरेशन ऑफ क्यूबेन इन द कमेंट बॉक्स. कमेंट बॉक्स में आंसर करना. दैट इज माय होमवर्क फॉर यू. ऑल द ड्रॉपर्स आउट देयर, वन होमवर्क फॉर यू. व्हाट इज द डिग्री ऑफ कमेंट बॉक्स में यू हैव टू गिव द आंसर. Degree of unsaturation for cubane. This question came in JEE. ठीक है? So you have to answer in the comment box. क्लियर है बच्चों? मुझे आंसर अभी मत दो, कमेंट बॉक्स, मतलब जब क्लास खत्म हो जाएगी यू हैव टू लेट मी नो इन द कमेंट बॉक्स कि ये आंसर आ रहा है, ठीक है? ऑल राइट, चलो बढ़िया, ऑल राइट। I also teach 11th course. I teach normal batch of 11th class in at Vedantu, but I don't take crash course. I take the long term batch. Okay, JEE batch. All right. So our next reaction जा रहे हैं. We are moving on to a next reaction. A beautiful question. Let me just erase this. हाँ जी. A beautiful question by Dhriti. Dhriti has asked many questions. He has been asking a lot many questions. Some students had asked previously also. Okay, Dhriti. So Dhriti is asking mechanism of Birch reduction in benzene. A beautiful question. कितने बच्चों को आता है? Let me know in the comment box कि sir we know already. And if you know, I will spice it up a little bit for you guys. Pay attention. Check this out. देखो, I'm doing Birch reduction in benzene, and I'll give you a bonus as well. So pay attention. Do not be in a hurry to go off right now. Pay full attention. ध्यान से सुनना. देखो, फर्स्ट टाइम बर्च रिडक्शन में बड़ा इंटरेस्टिंग है, जरा ध्यान देना. बिल्कुल सेम मैकेनिज्म है. आई एम टेकिंग सोडियम. सोडियम इज द सोर्स ऑफ इलेक्ट्रॉन. बेटा ध्यान देना, everyone will pay attention. This electron, boys and girls, what will happen? There will be, you know, this bond will break like this. Radical homolytic cleavage, just like this. And this bond, when it will be going here, this electron will pair up here. So basically, you will form an anion. यहाँ पे anion बन गया, यहाँ radical बन गया. अब बेटा, two negative charge cannot stay happily. So what will happen? It will undergo this kind of process. This is just happening. Let me tell you, this is happening. The sole purpose of this particular step is to cause stability, is to again regain the stability in the system, to regain the stability in the system, so that radical comes over here and the system is stable. Just to get stability, this radical has moved here. I hope this point is clear. Next step तो आपका favorite है बेटा. Next step is very easy. What will happen? Liquid ammonia will move. Obviously, Birch reduction is done in the presence of liquid ammonia. Liquid ammonia has H plus ion. बेटा बड़ा सिंपल दिख रहा है आपको, देख लो. Negative charge will attack here. You'll end up getting hydrogen, hydrogen, and H radical. I hope it is clear. Now repeat the process. ठीक है, अब रिपीट करना है यही प्रोसेस फिर से. बेटा बता रहा हूँ करता है सर, वो बताऊंगा. कॉन्जुगेशन ब्रेक अभी बताऊंगा, जरा सुनो. अब सुनेंगे यहाँ पर क्या होता है बेटा. फिर से आपका now what will happen in again? Sodium will come, and sodium is a source of electron. This electron will come over here, pairing हो जाएगी फिर से, right? What I will end up getting here? A negative charge. I hope it is clear. Next step again, liquid ammonia, H plus. Let me know what is the answer. You will end up getting 1,4 addition. You'll end up getting 1,4 addition. This is your Birch reduction of benzene. This is the compound which you will obtain. ठीक है, अब सुनो, अब बहुत इंपॉर्टेंट क्वेश्चन. दिस इज अ क्वेश्चन फ्रॉम Birch reduction. Now very important. बेटा what is the intermediate here? अगर आपसे पूछूं, if you notice here, what is the charge coming over on this one position, 1 and 4? What is the charge coming in on 1 and 4 position? Can you tell me what is the charge coming on 1 and 4 addition, beta? Kashmir, this is a case of benzene. ठीक है, carbon ion, right? Or carbon ion. So if I will put an electron withdrawing group at 1 and 4 position, it will be very good. So if you by chance have an electron withdrawing group in the system and benzene is given, and they are asking what is your answer when you have sodium and liquid ammonia, basically Birch reduction, beta, you'll end up getting 1,4 reduction. You'll end up getting electron withdrawing group. Sorry, not this. 1 second. Pay full attention. You'll end up getting 1,4 reduction, just like this. ठीक है, यहाँ पे हाइड्रोजन, यहाँ पर हाइड्रोजन. But beta, what if I will say But beta, what if I say you have an electron donating group? What if I say you have electron donating group, and you know in between this process, electron donating group. In this process, what is formed? There is a carbanion formation. So basically, it will try to avoid it. It goes for 1,4 addition. Instead of 1,4 addition, it goes for 2,5 addition. My bad. It goes for 2,5 addition. यहाँ पे electron donating group, the bonds would be formed like this. I hope you understood the logic. I hope you understood the logic. सबको logic clear हो गया. Clear? Because this is 2,5 addition. This addition is called as 2,5 addition. But in previous case, which I have told just now, now pay attention, very important, this gist of it. If I will have electron donating group here, liquid ammonia, what I will end up getting, beta? What I'll end up getting here? You got it, right? If I have electron withdrawing here, electron withdrawing group here, I'll get 1,4 addition. This is the point I wanted to add here. Extra information I have added. Electron withdrawing group, 1,4 addition. This is called as 1,4 addition. Take a screenshot. It's a very important point. Take a screenshot. Take a screenshot. Very good. I hope सबको clear हो रहा है. I hope this point is clear because this is a very good information I have tried to give in here. Was it useful? Was it useful, beta? समझ आया? क्या मैं आगे बढ़ जाऊं? Do I have the permission to move on? You can take a screenshot. Another name of mechanism, bhai Kuncha, you can check it out. What, as far as I remember, it is Birch reduction only, and this is a special case of it. If you find out, if you get the idea of it, please drop in the comment box. Drop the answer in the comment box. Definitely, है ना? All right. आगे बढ़ूंगा. Moving on. पूरा यहाँ दे रखा है, which I have already explained to you guys. Now next question is from इसकी तरफ से है ये question. This question is from Athar from Kota. Athar has been asking कि sir, why we require acidic and basic, slightly basic and slightly acidic condition for the coupling reactions of phenol and aniline respectively. Is there any advantage in taking high acidic or basic medium? Disadvantage, I'm sorry. Is there any disadvantage in taking highly acidic or basic medium? All right. Who wants to answer why you require basic medium when you do coupling with phenol? Can anyone let me know? Can anyone tell me why do we require basic medium in the coupling process of phenol with, of course, your favorite BDC? Anyone let me know in the comment box. Phenol has OH group. Some of you are giving right. Disha has said, देखो बेटा, बड़ा simple logic. Phenol, when you will do it, react it in basic medium, it will form phenoxide ion. Beta, let me know about one thing. Phenoxide ion, which effect would be happening here? Plus M or minus M? What is the effect here? Beta, when you add basic medium, phenol converts into phenoxide ion. What is the role of it? Why I am talking about it? Because it has strong O minus. This entire group is a very strong plus M and plus I group. Of course, where plus M is very strong. It is going to increase the electron density in the benzene ring efficiently. As a result, it can attack the electrophile very, very easily. What is the electrophile here? Your favorite BDC. Correct? क्या मेरी बात समझ पा रहे हैं? और मैं इसको ऐसे लिख देता हूँ, this is your electrophile. So this electrophile gets attacked by a phenoxide ion very easily. What will happen? I'll show you here. Check this out. Check this out. बड़ा आराम से. It can form a negative charge here. This negative charge will attack on your favorite BDC. ठीक है, इस पे अटैक, कपलिंग रिएक्शन बड़े आराम से हो जाएगी. I hope it is clear. This is point number one, right? This is point number one. That's why weak condition is required. ठीक है, ये बढ़िया रहता है. Disadvantage will make sure. Disadvantage. What is the disadvantage, beta? If I will take strong basic medium, my phenoxide ion would be destroyed. Basically, this if I take very strong medium, the reaction, acid-base reaction will happen, and my efficiency of the phenoxide ion, which is actually helping in this particular attack, will be dropped. Will be the reaction will no longer be efficient. That's why we don't take strong basic medium. Similarly, you have also asked one more thing, Athar. You have asked why we are using slightly basic medium, sorry, slightly acidic medium in the case of aniline. Beta, what you are doing here, very important. Check this out. Why it is required? Why it is required? I tell you. बहुत इंपॉर्टेंट चीज. नाइट्रोजन हैज ऑलरेडी लोन पेयर ऑन इट, so it can actually undergo pairing. An unwanted reaction is will come. This is not the coupling product which we want. If we will not use any kind of, if it is not used, if any kind of acid, slightly acidic condition is not used, we will actually end up getting a different compound which is not required. जो हमें नहीं चाहिए वो मिल जाएगा, जो हमें नहीं चाहिए वो मिल जाएगा. ठीक है, अच्छा, मेरी बात समझना, जो हमें नहीं चाहिए वो मिल जाएगा. सो दैट्स व्हाई व्हाट वी डू, वी मास्क आवर NH2. दिस अटैकिंग टेंडेंसी ऑफ NH2 वी ट्राई टू डिक्रीज, वी ट्राई टू डाइल्यूट इट डाउन बाय एडिंग HCl. हम HCl से इसको प्रोटेक्ट करा देते हैं. दिस इज व्हाट द रिएक्शन व्हाट हैपेंड. वी डोंट वांट दैट रिएक्शन. प्रोटोनेशन ऑफ aniline avoids this side reaction. What we do, we make anilinium ion. We make anilinium ion, that too in dilute condition. Now the reaction can happen easily. The lone pair present on nitrogen will not attack. क्या मेरी बात समझ आ गई? And coupling reaction can happen what we want. ठीक है, I hope it is clear. सबको बातें समझ आ गई हैं, क्लियर हो गया है? Yes, कलर में मैं नहीं जा रहा, आप कलर बात सही कह रहे हो. I am not talking about colors. I am talking about the normal use. Why we use acidic and basic medium. I repeat again, I conclude again. Why we require your basic medium in the case of phenol. काफी contradictory बात है, right? It is kind of a contradicting statement. Why we take, or irony समझ लो, it's just like an irony. In phenol, which is acidic, I am taking basic medium, so that phenoxide would be produced, and phenoxide actually is increasing the electron density in the benzene ring efficiently. As a result, it can attack on the electrophile and form better coupling products. Similarly, if I talk about your aniline, aniline is already very activated. The lone pair present on it can give us side reaction, which we do not want. The coupling is not sufficient. This is not the right coupling which we prefer, right? So, in order to avoid this, you actually can limit the tendency of nitrogen to attack. So you are masking it by adding slightly basic medium. It's also an irony, right? I hope ये आपको बात समझ आ गया है. Is this clear? I hope it is clear. ठीक है, आगे बढ़ रहा हूँ. Next up is bare villager oxidation. Beautiful यार. How many of you know this यार? How many of you people out there, how many of my sailors out there know this reaction already? आपको ये reaction आती है? Let me know. अरे लाइट आ रहा है, आई एम सॉरी, जस्ट लेट मी फिक्स द लाइट. काफी लाइट आ रहा है पीछे से, जस्ट गिव मी अ सेकंड. ऑलराइट, तो काफी बच्चों को नहीं आ रहा है. It's a beautiful method of converting ketones into esters. बहुत सिंपल रिएक्शन है. इफ आई विल टीच यू, यू विल से सर समझ आ गया, बड़ा आराम से रिएक्शन आएगा समझ. देखो, this is a ketone. In this reaction you use per acids, right? Let's take as per acetic acid. It is nothing but CH3 C double bond OH OOH per acetic acid, right? You'll end up getting R1 C double bond R2. ester मिल जाएगा. This is the reaction. Now let us understand. भुवनेश्वर से Swasti has asked this question. So Swasti, pay attention, pay full attention. It's a very, very beautiful reaction, and I have a very simple mechanism for your understanding. You have to pay full attention. ठीक है? काफी आपको attention देना पड़ेगा. ध्यान से सुनना. Let me do it on the another page. Let me do it here. ठीक है. So देखो, what I will do here. Check this out. R1 C double bond O R2. I am adding here per acetic acid, or I am taking a general form, right? PCOOH. But this is an acid which can give you RC double bond O minus. Side side, you will also get H plus. Beta, oxygen has lone pair on it. Oxygen has lone pair on it. This lone pair will attack here, right? And you'll end up getting this minus charge will attack here. Simultaneous attack will happen, boys and girls. So you'll end up getting RC. Check it out, very interesting here. OH, right? And here, this you will get as O C double bond O, C double bond O, right? And here R. अच्छा, I hope it is clear. ये पूरा समझ आया है. Everyone understood up to here. ये clear हुआ. This is R1, this is R2. Pay full attention. Now it is very, very important. Beta, you guys know that this is peroxide linkage, or this is a peroxide bond, and peroxide bonds are weak. Peroxide bond क्या होता है? Weak होता है. So beta, this bond will break. This bond will break. This bond will break, and as a result, for a brief moment, you guys agree with me? So let me know in the comment box. For a brief moment, on this oxygen, positive charge will come. Is it a stable arrangement? Do you agree कि यहाँ पर positive charge आएगा? Would there be positive charge for a brief moment? Yes or no? Just say yes or no in the comment box. Waiting for your replies. For a brief moment, who's saying no? यार क्यों नहीं आएगा? देख भाई, ये bond टूटेगा, electrons लेके इधर अपने तरफ shift हो रहा है. This bond is breaking. O minus is trying to come out, right? So for a brief moment on this oxygen, positive charge would be formed. I am trying to understand this, I am trying to tell this point. But you know, oxygen pe positive charge is not stable. Positive charge on oxygen is not stable because oxygen is a very electronegative element. So this R group will say, oh, don't worry, oxygen, I'll sacrifice for you. I'll give a shift. I'll do an alkyl shift. As a result, you will never get a positive charge on it for a very long duration, right? As a result, what you end up getting is an alkyl shift, 1-2 alkyl shift. And boys and girls, this step is a very slow step. And here migration aptitude is strictly followed. यहाँ पे migration aptitude is strictly followed. What you will end up getting, check this out. You'll end up getting R2 C double bond O, C double bond O R1. Your ester is complete. What is important? Migratory aptitude is strictly followed. Your ester is complete. Here migratory aptitude is strictly followed. यही आपको याद रखना है. Migratory aptitude is strictly followed. What is that? H minus, then pH minus, then CH, 3 degree alkyl, then 2 degree, then 1 degree, then CH3 minus. These are alkyl groups. Are you getting the point? सबको समझ आया? मैं फिर से रिपीट करता हूँ. I'm repeating my points again. Pay full attention. Not tricky if you pay full attention. बहुत ध्यान से सुनना. Let's do one thing, क्योंकि मैंने आगे उसको वो बोला है. Let's do one thing for you guys. Check this out. Pay full attention. I am telling again. एक एक स्टेप समझा रहा हूँ वापस. देखो, I hope up to now you understood this step. So everyone understood this first step. Everyone understood. Now check this out. I tried to tell you here that peroxide bond is a weak bond, so it will break like this for a brief moment on this particular, on this particular oxygen. A positive charge would be generated for a brief moment. On this particular oxygen, a positive charge would be generated. If it is generated, beta, that is wrong, because positive is an electronegative element. So what will happen? This R2 group will say, "Bhai, don't worry, I'll help you out. You are my friend, Macha. I'll come here and I'll sacrifice myself. I'll come as an alkyl and I'll make sure you do not get a positive charge on you because it will make you unstable. As a result, it will move here. ये पहुंच गया यहाँ पर attack मार के. This shift is called as alkyl shift and it is a slow step. And here migratory aptitude is strictly followed. And what will happen? Counterproduct. This will move here. So I have written the same stuff. So देखिए R1 remain here. C double bond O, oxygen went, now R2 is attached to this oxygen, this particular oxygen. R2, this is ester. Now the question will come where I should trick. I'll tell you a trick. Wherever the migratory aptitude of a group is more, whichever group has higher migratory aptitude, that side you will put O. That's it. Mechanism nahi bhi samajh aaya. Remember, it follows migratory aptitude. Remember, it follows migratory aptitude. This migratory aptitude is strictly followed. Remember this. Okay? Let me give you a question on it, by which you will understand very easily. Check this out. So CH3, C double bond O, CH3. Adding here peracetic acid, PAA. It is called as peracetic acid. Right. Similarly, I'm adding CH3, C double bond O, ET. CH3, C double bond O, tertiary butyl. Right. CH3, C double bond O, OH. Guys, give me the answer now. Quickly give me the answer. अब बताओ. Anywhere you put doesn't matter. Symmetrical compound doesn't matter. Very good. What about here? Where shall I put O? कहाँ पर O लिखूं? Migratory aptitude is strictly followed. Right side O लिखूं, left side O लिखूं. Which side I should put? Right side O shall I put? Or left side? Shiva has given answer. Very good. Bachmann. It is Bachmann. Bachmann. ठीक है? Right or left? R or L बोल दो भाई. Give me the answer. Right or left? हाँ जी. Don't leave me hanging. Yes. Very good. So you got the gist. ठीक है? कुछ नहीं करना. Is it an easy reaction? Did I make it easy for you? What about this one? Right or left? Right or left? Migratory aptitude is strictly followed. What is migratory aptitude? H minus, pH minus, 3 degree, 2 degree, 1 degree, methyl. Everywhere right. CH3, C double bond O, OET. इधर अरे यार मैं तो हाँ आंसर ही लिख दिया यार, माफ करना. I have just given the answer here. Here which side? Right or left? Here also right. क्या मजा आ रहा है? Are you getting it? यहाँ पे एसिड बन गया. So I have given a different question. Pay attention to this question. It was a good question. Did कितने बच्चों को how many of you got this for the very first time? Was it useful? You got it for the very first time. Now you understood it. Like आपको समझ आ गया है. Let me know. How many of you got it? I will be very happy to see that. अगर आपको समझ आया है, if you understood it and you liked it, please make sure you like the video, you subscribe to the channel, and definitely hit the bell icon, right? So you have to do me a favor, share this, like this, subscribe to this channel, right? This is a humble appeal, right? अगर आपको कुछ value मिली है, तो you have to stick to it, right? All right, moving on. आगे बढ़ेंगे. ये सब information आपको मिल जाएगा. I have given full mechanism. ठीक है. Next one is Michael addition. Sir, please help me. Thank you in advance, Captain. This is anonymous. The guy wants to be anonymous or the girl wants to be anonymous, and he or she is from Chennai. So, bacha, pay attention. I have this answer for you. Michael addition or Michael reaction, basically, whenever you have to attack a nucleophile on a carbonyl compound, and the carbonyl compound has alpha beta unsaturation on it, then the attack will happen in 1,4 manner. Not in 1,2 manner, but in 1,4 manner. मैंने बहुत सारी बातें बोल दी. I said a lot many things. I don't know if it is clear or not. Let me give you Michael addition by an example. Beautiful, बहुत famous example. That is Gilman's reagent, right? Gilman's reagent. Whenever I will take a very bulky carbonyl compound like this, right? If I take RMgX reacted with CuLi, do hydrolysis. This is nothing but Gilman's reagent. Beta, this particular compound will give me 1,4 addition. I'll end up getting RC double bond O here, CH2, CH2, R dash. This is called as 1,4 addition. क्या बोला जाता है इसे? 1,4 addition. Whereas your Grignard reagent, if I would have created Grignard reagent, R minus would have attacked on carbonyl compound. पर यहाँ पर ऐसा नहीं होता. This doesn't happen here. This addition, whenever a very bulky nucleophile or a carbonyl compound which is having unsaturation on it, a carbonyl compound which is having an unsaturation on it, that too conjugated. This is a carbonyl compound having unsaturation on it. Then what will happen? This will give you 1,4 addition. कौन सी addition? 1,4 addition. Do you want to know the mechanism? Do you want to know the mechanism? Do you want to know the mechanism? Let me know. Mechanism सीखना चाहोगे? Kajal is saying no, I don't want. Want to learn the mechanism? अगर बोलोगे हाँ तो सिखाऊंगा. No. Yeah, I'm giving example of Michael addition with the help of Gilman's reagent. तो देखो, pay full attention. Right, let's say this is our compound. All you have to do is add here Gilman's reagent. I'm adding, this is another way of writing Gilman's reagent. RMGX CUI, let's call it as R dash, and hydrolysis. This is another way of writing Gilman's reagent. Otherwise, you can also write R2CuLi. You are most welcome. This is another way of, they will confuse you as if it is this particular compound, as if this particular compound is your Grignard reagent. ऐसे confuse भी कर सकते हैं. Many times they do that. Many a times they do that. ठीक है? अच्छा. So now pay full attention. Now what is the answer I'm trying to tell you with the help of mechanism? Check this out. R C double bond O CH2 CH, यहाँ पे CH आएगा, sorry, CH, this one, right? This R minus beta, R dash minus will attack here. Something like this will happen. Check this out. What you'll end up getting, sorry, R CO minus double bond CH CH R dash. Correct? ये आपको दिखेगा आते हुए. Now what will happen? Next step, what will happen? H तो रहता ही है. I'll end up getting RCOH double bond CH CH R dash. Next step is tautomerism. यहाँ पे tautomerism हो जाएगा. It will undergo tautomerism. I'll give you a trick. Don't worry. कि sir, how much we have to learn? No worry. I'll give you a trick to remember. So at the end, this particular proton will go back. Check this out. So you'll end up getting R C double bond O. जो आपको पहले मिला था वही मिल जाएगा. CH double bond CH R dash. One step answer. What you have to do? Just attack on the double bond. Just attack on the double bond. That's it. This is the one step answer trick. 1 second की trick. One step answer. Do not do anything. This much is not required. ये सारी चीजें, this is not required. All you can do in one step, right? सीधे attack कर दीजिए on this particular position. The nucleophile will attack on this position and hydrogen will come on this particular position. That's the trick for answering this one. ठीक है? Is this clear? Difficult लग गया तो एक example देखो, आसान हो जाएगा. I'll make it easier for you. देखो difference समझाता हूँ. Let's do a. देखो जरा ध्यान देना. Everyone will pay attention. Same question. One time I'm taking RMGX, right, and doing hydrolysis. Check the answers, difference in the answer. Another time I'm taking here your favorite first one. I'm taking RMGX, second step CULI, right, and then यहाँ पर मैं डाल दिया third step is your hydrolysis. So this is your Gilman's reagent. This entire setup is for Gilman, right? अब सुनो, this will give you 1,2 addition, normal addition. R minus generated will attack here, and you'll end up getting an alcohol. आपको alcohol मिल जाएगा, correct? Nothing will happen. But if I take Gilman's reagent, beta, what will happen? This will become OH. Sorry, this will remain as it is. There will be no 1,2 addition. There will be no 1,2 addition. कोई 1,2 addition नहीं होगा. यहाँ पर कोई 1,2 addition नहीं होगा. ध्यान देंगे सारे. बड़ा ही important point है. No 1,2 addition. हाँ जी. तो यहाँ पर ये रहेगा double bond O. There will be 1,4 addition. R Me over. This is your answer. This is called as 1,4 addition. If you have not learned this question has come in advance. ये एडवांस में आ चुका है. Gilman's reagent gives you 1,4 addition, whereas Grignard reagent will always give you 1,2 addition. Please make a screenshot of it. ये आप देख लीजिए. I hope it is clear. Very very important mechanism I have also given. If you don't want to learn the mechanism, you can actually go ahead with this. सीधे सीधे आप याद कर सकते हो. Right the way I have told you in one step. ओके बढ़िया, सब कुछ मिल जाएगा. ये है ऑल राइट. बेटा दिस क्वेश्चन अगेन केम अप इन जेई. तो जेई में आया हुआ है, एंड आई हैव टॉक्ड अबाउट दिस क्वेश्चन अ लॉट इन किलर 5 सीरीज आल्सो. अच्छा, किलर 5 सीरीज is basically a series in which I have taken up all advanced questions. सारे advanced level questions I have taken up there, and all previous year advanced questions I have taken up. If you want to learn it, if you have never watched it, it's the time for you to actually go and check it out. Every advanced level question, I have done a series called Killer 5 series, where I have taken five difficult questions from various advanced level questions, okay? Advanced level papers. So you can check it out by yourself. I am attaching that particular series screenshot on the particular PPT. In our class PPT, I'm adding it as well, and you can check it out. Link is also there in the description box. Okay, link is also there in the description box. Otherwise, type just Killer 5 series. You will get a good practice of advanced level questions. Okay, and here answer is KOH. Very 4 KOH would be taken up. 2 would be taken up during the mechanism process when alkyl isocyanate is formed, and then when alkyl isocyanate will form, will undergo hydrolysis, it will take 2 more OH minus. दो और OH minus ले लेगा. And another testament of this particular thing is you end up getting K2CrO3. 1 mole of CO2 absorbs 2 mole of KOH. Since you are getting K2CO3, you can also infer from there that 2 moles of KOH must have been absorbed by CO2 gas. Another way of understanding it is this. सबको समझ आया? I hope it is clear. This is also another way of understanding, because at the end I am giving you a simple homework. Check out the Killer 5 series. I have discussed the name proper reaction. हर चीज दे रखी है. And if you notice the reaction, you'll end up getting K2CO3. And 1 mole of CO2 can absorb 2 moles of potassium, KOH basically. So as a result, 2 moles must have been observed. 2 moles must have come out. Definitely 2 moles more must have come out. दो पहले थे, 2 were there before and 2 were there after. Hence, how many moles of KOH was required? 4 moles of KOH were required. All right. Please explain Perkin reaction. It is by another student. Perkin reaction बताना है. Perkin reaction, beta, question again came up on Perkin reaction, and the question was very simple. Question was, Perkin reaction is actually used for benzaldehyde. Perkin reaction was used for aromatic aldehydes. In other words, it is used for aromatic aldehydes. When you react aromatic aldehyde with anhydride, in the presence of the salt, जरा ध्यान देना, salt कौन सा है, I will explain. Boys and girls, you'll end up getting cinnamic acid here in this particular case. PH, C double bond, CH, COOH. You'll end up getting cinnamic acid. If I have to teach you a trick, pay attention. Trick देखो, JEE में question क्या आया था? What was JEE question? They had given aromatic aldehyde. They had given anhydride. Beta, whatever the anhydride you will take, whatever the acid anhydride you will take, of the same acid you have to make the salt of. You have to make the same, whatever the acid you are taking in acidic anhydride, that acid must be used in the preparation of the salt, right? So if you see, I am taking acidic anhydride. So I have taken up a salt of sodium or potassium salt of acidic acid. This question came in JEE. If I am taking acidic anhydride, then what should be my salt? It should be of the same acid which is used in anhydride. In anhydride, I am taking acidic anhydride or acetic acid. The salt will also be of the same acid. So I am taking sodium or potassium salt of acetic acid. This question was from JEE. So I have given you a JEE problem here. Is that question clear? सब कुछ समझ आया? This is a very important way of understanding this. And yes, ट्रिक तो बहुत आसान है टू रिमेंबर. ट्रिक तो बहुत आसान है. ट्रिक सुनो, ट्रिक तो बहुत आसान है. CH डबल बॉन्ड O. No need to go in mechanism. Mechanism I have also attached, but I am telling you trick which will help you a lot. देखो क्या करना है, पानी निकाल देना है. Remove water and this bond you cut. Put OH, H. Done. That's what I have done. Check this out. Yes or no? Did you understand the trick? मैकेनिज्म समझाऊंगा, ट्रिक समझ आया? पानी निकालना है, काट देना है. Is this clear? I hope it is clear to everyone. Question: it is not valid for aliphatic, it is only valid for aromatic. Perkin condensation or Perkin reaction happens only for aromatic aldehyde. That's one condition. Similarly, whatever the acid anhydride you have taken, of the same acid you have to prepare the salt of. Salt is prepared by the same acid. Very good. All right. So this is our mechanism. Let's understand the mechanism. Very simple mechanism. Pay full attention. CH3 C double bond O C double bond O CH3. So you have taken a very strong base. This is a very strong base. This will come and abstract your acidic hydrogen. Why we require a strong base? Because this is not a very strong acidic hydrogen. This is not a very strong alpha H, or this acidic nature here is less. That's why we require a strong base to abstract the proton. You'll get CH2 minus C double bond O C double bond O CH3. This is step number 1. Step number 2. Check this out. Now your benzaldehyde is here, ready and waiting. It has partial positive charge on it. This will attack, Mardo attack. What I will get? I'll get PH CHO minus. Here I will get CH2 C double bond O C double bond O CH3. I hope everyone can see. सबको दिख रहा है. I hope everyone can see. Right. Next step to beta, obviously you know water would be there. So this will become PH CHOH CH2 C double bond O. अब यहीं पर आप ये काम कर दो, break it. What I will end up getting? I'll end up getting COH, but this process will not stop. Later on, what will happen? H and this hydrogen, one hydrogen will go off. Minus water, थोड़ी सी heating होती है. पता, it is not mentioned in Perkin, but there is light amount of heating as well. Then only this reaction will happen. So you'll end up getting your favorite cinnamic acid. सबको cinnamic acid ऐसे मिल जाता है. I hope it is clear. Why same acid is used? This question came up. Why same acid is used? To get the better yield, so that more mixture of product is not formed. जिससे आपकी efficiency of the product would be more. As you can notice, it is attacking, right? If I will take different base, there is a possibility that we will get different nucleophiles or not of the symmetrical. Basically, we try to make the symmetry so that the end product will be of maximum yield. Yield के लिए सब कुछ काम हो रहा है. ठीक है? If you will take different acid, yield will not be effective. Clear हुआ? Ketones do not give this reaction. Perkin reaction is only given by आपकी aromatic aldehyde. Alright, so that's it. ठीक है बच्चों? बढ़िया. तो पर्किन हमारा यहाँ पर खत्म हुआ. मैकेनिज्म आपको दे दिया है. You can check out the mechanism. And this is a simple question. I'm pretty sure you can solve it now. Right? यहाँ पर पर्किन के बाद अटैक हो गया एक्स्ट्रा. Right? What has happened here? You formed basically what has happened here. Can anyone tell me in this question what has happened? Let me write it from step 1. I'll show you the end thing where we have most of us would be getting the answer. सबका इतना आया होगा. Then beta, what has happened? Esterification. Then what has happened? Esterification. Correct? Then what has happened? Esterification. Clear? समझ आया? क्योंकि यहाँ OH था. वाटर बाहर. Alright, तो ये देखते हैं. Alright, so this is what I was talking about. This Killer 5 series beta. All advanced level question has been given out here. You can check them out if you want to learn some advanced questions. This Killer 5 series, if you have not checked it out, do go ahead. Do check it out. Check it out now. Acha. Similarly, beta, if you are not on Vedantu's Telegram, you have to be a part of it, because what is happening there, boys and girls, we are posting a lot many questions, lot much activity, lot many activities are happening here, so you can actually see and get the assignments and be updated when your favorite teacher is coming online. Okay, so join this. And yes, I have talked about the crash course, the importance of the crash course. If you want to do more advanced level questions, want to be learning every time, you want to be regular with your studies and everything, you want to have a proper curriculum, you don't want it like, you want to be properly, you want to be focused, then I will suggest you be a part of this crash course, which is starting from 27th April, and it will be very, which has actually started from 27th April. It will be very effective for you guys. काफी amazing रहेगा. You have not missed out a lot many things. You have not missed on anything. You can be a part of it. ठीक है बच्चों? Check it out. It's very amazing. It's very good, right? And you will use this coupon code, you will get a heavy discount. Okay? Thank you so much. That's it for me today. I hope you have liked the session and I have tried to give you something new. That's it for me today. See you next time. Thank you so much. Bye bye.